Let's clear one thing up right from the start. The story isn't that China decided to build its own chip machines. Everyone knows they've been trying for years. The real story is the sheer, deafening silence that followed their announcement. When China claimed a breakthrough in domestic lithography, the West didn't erupt in panic. No sirens went off in Washington or Brussels. Instead, the reaction was a collective, skeptical eyebrow raise. You could almost hear the quiet murmurs of, "Yeah, right," from boardrooms to intelligence agencies. Here's the thing. In the high-stakes poker game of semiconductor supremacy, a bluff is always a possibility. Think about what we're really talking about here. Lithography machines are arguably the most complex devices ever mass-produced by humankind. They are not something you simply invent in a backroom lab. They represent a century of cumulative global scientific progress. So when a nation under severe technological blockade says, "We've built our own," skepticism is the first logical card to play. But why is the skepticism so intense, so uniform? Is it just strategic disbelief, or is there something more concrete behind it? We need to rewind a little. For decades, the global chip supply chain was a model of intricate interdependence. American design software, Japanese specialty chemicals, Dutch masterpiece machines, Taiwanese manufacturing prowess. It was a delicate, profitable dance. China was a major participant, but largely as the world's factory floor for assembly. Then the music stopped. Geopolitical tensions turned chips into weapons. Export controls came down like a guillotine, severing China's access to the most advanced tools. The goal was clear: cripple China's ability to make the brains of modern warfare and AI. So China's announcement wasn't just a technical bulletin, it was a geopolitical counterpunch, a declaration of technological independence. But wait, declaring independence and actually achieving it are two very different things. Ask any engineer in Silicon Valley or Eindhoven what it takes to build an EUV lithography machine. They'll describe a system that projects patterns onto silicon using light as thin as a soap bubble is film. It requires mirrors smoother than a pane of glass stretched to the size of a continent. The precision is almost incomprehensible. Now, could China have secretly mastered this art in isolation? That's the billion-dollar question haunting Western capitals. The initial reports from Chinese tech forums and state media were, predictably, triumphant. They spoke of 7-nanometer chip production without ASML's legendary EUV machines. They showed images of shiny new equipment branded with Chinese logos. The message was one of defiant self-reliance. Yet, the official statements were carefully worded, often vague on the specifics of yield and true capability. And here's where the Western narrative forms. Analysts immediately began picking apart the claims. "Show us the chips," they said. "Prove the yields are commercially viable. Let us see the machine in action for more than a staged video." The skepticism is rooted in a deep understanding of the ecosystem. Building a prototype is one thing, but can you manufacture hundreds of these machines with reliable consistency? Can you source all the advanced components now also under embargo domestically? That's the real mountain to climb. So the US Commerce Department gave a tight-lipped, "We are monitoring" response. European officials exchanged concerned but dubious glances. The CEOs of major chip tool companies publicly downplayed the threat, citing the decades of know-how advantage. But privately, you can bet they're ordering their intelligence teams to find the hard data. Is this just wishful thinking on the West's part, a hope that the problem will simply go away? Or is their skepticism a well-informed assessment of a nearly impossible task? The silence, you see, is not just doubt, it's a strategic pause. It's the calm before either a storm of proof or a quiet admission of a bluff called. But wait, to truly understand the weight of this moment, we have to look at what China was actually cut off from. What exactly did the West think it was denying them? And what desperate all-in alternatives did that blockade inevitably force China to pursue? Let's pull back the curtain on what those export controls actually blocked. It wasn't just a single machine they couldn't buy. It was an entire universe of technology. Think of it as a high-tech siege, designed to starve China's chip ambitions of critical oxygen. The crown jewel target was, and is, ASML's extreme ultraviolet EUV lithography machine. Each one costs over $150 million and is the size of a city bus. Without it, making chips at the bleeding edge, think the processors in your latest iPhone, is practically impossible. But here's the thing. The blockade went much deeper than just the final product. It extended to the very tools that make the tools. Precision lenses, advanced light sources, even the software that calculates how to bend the light. The US and its allies targeted a vast web of know-how. So the challenge for China wasn't just to build a lithography machine. It was to recreate a miniature version of the entire global tech ecosystem, from the ground up and within its own borders. Can you imagine the scale of that endeavor? We're talking about mastering disciplines from quantum physics to advanced metallurgy all at once. Now, this is where China's alternative path gets interesting, and where Western skepticism meets genuine technical curiosity. Faced with the EUV wall, Chinese engineers reportedly took a detour. They allegedly turned back to an older, more understood technology called deep ultraviolet DUV lithography. But they pushed it to its absolute theoretical limits. The process is called multi-patterning. It's like using a stencil, but you have to layer it perfectly multiple times to etch the ultra-fine lines needed for an advanced chip. It's incredibly complex, slow, and hurts your yield, the number of good chips you get from a silicon wafer. But wait, if it's so messy and inefficient, why would they bother? Because it's possible, and because it doesn't require the forbidden EUV tools. This is the core of China's claimed breakthrough, doing an end run around physics with sheer manufacturing grit and clever workarounds. They're essentially using a precision sledgehammer to do a laser scalpel's job. So, when the reports of 7-nanometer chips emerged, Western analysts nodded. They'd seen this movie before. Companies like Intel and Samsung used multi-patterning for years before EUV was ready. It's brutally difficult and expensive, but not magic. The real question isn't, can they make a few chips? It's, can they make 1 million chips, reliably and cheaply enough to matter? That question hangs in the air, unanswered. And the silence from the West is partly because they are looking for a specific kind of evidence. They're waiting for signs of commercial adoption. Are Chinese smartphone makers like Xiaomi willingly using these domestic 7-nanometer chips in their flagship phones? Or are they still scrambling for any available imported chips? Are the yields high enough to be anything but a subsidized prestige project for the military? You see, in the chip world, economics is the ultimate truth teller. A lab success can be a commercial failure. The West is betting that the economic disincentives are still too great. But what if that bet is wrong? What if China is willing to absorb astronomical costs for a decade, just to break the dependency? That's the unnerving part of the calculation. The skepticism, therefore, is laced with a nervous undercurrent. It's the hope that the laws of physics and economics will hold, but it's the fear that a national, state-funded effort can bend those laws further than anyone in a free market thought possible. Look at the massive government-backed big fund pouring billions into Chinese semiconductor firms. Whole cities are being built around chip fabrication. This isn't a corporate R&D project, it's a national moonshot. So when a Western CEO scoffs at the technical hurdles, they're not wrong, but they might be missing the bigger, more political picture. The goal for China right now may not be profit. It's pure survival and sovereignty in the digital age. Is the West's market-driven model even equipped to understand that kind of relentless, cost-be-damned determination? This brings us to the human element, the brainpower behind this push. Where did China suddenly find the engineers to take on this Herculean task? And what happens when you trap a generation of brilliant minds inside a technological fortress with one singular mission? The brainpower question cuts to the heart of the mystery. You don't just conjure teams of lithography experts out of thin air. Here's the thing. China's talent pool has been decades in the making. Think of it as a strategic investment finally being called due. For years, top Chinese students flooded into graduate programs at Stanford, MIT, and the University of Texas. They worked at Intel, Applied Materials, and yes, even at ASML itself. They learned the gospel of the global semiconductor church. Then, the geopolitical winds shifted. Many returned home, by choice or by circumstance, carrying that invaluable knowledge with them. This created a unique, and from the West's perspective, problematic brain circulation. But wait, is that enough? Knowing how to operate a system is a world away from knowing how to build one from scratch. It's the difference between being a master chef and forging your own oven, mill, and cutlery. This is where the real underground battle is happening, in the gray zones of knowledge transfer. The U.S. Department of Justice has brought case after case against individuals for allegedly stealing trade secrets. It's a constant game of cat and mouse. Yet the larger, more legal transfer happened already, through years of open collaboration and published research. The foundational physics of lithography isn't a secret. The secret is the 10,000 tricks of the trade, the tribal knowledge etched into the hands of technicians who've calibrated machines for 30 years. So could China accelerate past that experience gap? They're trying with a brute force approach that mirrors their industrial policy. Throw 1,000 teams at 1,000 problems. Run simulations around the clock. Test, fail, and test again on a scale that would bankrupt a private company. It's innovation by sheer volume of effort. But does that model produce elegance or just functional clunkiness? That's what the skeptics are really questioning. Look at the history of technological catch-up. It took Japan and South Korea decades to move from copycats to leaders, and they did it with full access to the global market. China is attempting the same climb, but with a heavy backpack of restrictions. Is that even possible in our interconnected age? The answer might lie in a surprising place: the sheer size of China's domestic market. It provides a crucial shelter, a testing ground. A chip doesn't need to be the world's best to be useful in a smart thermostat, an electric vehicle, or a surveillance camera. This allows for a gradual improvement loop. sheltered from international competition. So, are we watching a slow, inevitable march toward parity? Not so fast. The West isn't standing still either. While China works on mastering today's technology, the leaders are racing toward tomorrow's. ASML is already developing high-NA EUV, the next-generation machine that will make current tech look primitive. The goalposts are constantly moving. This creates a nightmare scenario for Chinese planners, finally achieving a difficult breakthrough, only to find the industry has already leaped ahead once more. It's like running a marathon where the finish line is always getting farther away. So, the skepticism from the West is also a product of this forward momentum. There's a confidence that their own innovation engine, though messy and capitalist-driven, is still unmatched. But is that confidence justified, or is it a dangerous complacency? History is littered with giants who underestimated determined underdogs. The US remembers the Sputnik moment all too well. Could this be their lithography Sputnik? A shock that proves a focused rival can close the gap faster than anyone predicted? This brings us to the most tangible evidence of all, the chips themselves. In the absence of transparent data, the world's tech detectives have turned to forensics. What happens when you physically tear down a supposedly advanced Chinese chip and put it under a microscope? The silicon, it turns out, can't lie. The silicon forensics tell a fascinating and ambiguous story. Independent analysts like Tech Insights did what the world was waiting for. They pried the lid off a Huawei smartphone. Inside, they found a 7-nanometer processor, the Kirin 9000s, manufactured by China's SMIC. Here's the thing, the chip was real. It was functioning, and it was undoubtedly produced without a traditional EUV lithography machine. The initial wave of Western skepticism had to adjust, but it didn't shatter, because under the microscope, the tale got more complicated. The chip showed signs of strain, literally. The circuitry had minor imperfections and a higher transistor density variation than you'd see from TSMC or Samsung. It was a masterpiece of engineering grit, but it lacked the refined elegance of a chip made with better tools. It was the technical equivalent of a breathtaking piano piece played on a slightly out-of-tune instrument. You admire the skill, but you can't unhear the struggle. But wait, what does struggle actually mean in a geopolitical context? For a smartphone giant used to 90% yield rates, a 50% yield is a disaster. For a nation seeking technological sovereignty, a 50% yield is a starting point. This is the fundamental disconnect in the entire debate. The West measures success in quarterly profits and market share. China may currently be measuring it in binary terms. Can we make it? Yes or no? So, the forensic evidence confirmed two opposing narratives simultaneously. The skeptics said, see, it's harder, costlier, and less perfect. The proponents in China said, see, we did the impossible. Both were right. Now, the reaction in Washington and allied capitals shifted from pure doubt to calculated concern. The tone became, okay, they're further along than we thought, but at what cost? New, even stricter export controls were rolled out, targeting the older DUV machines China was so cleverly exploiting. The goal became to choke off even the workaround path. This created a bizarre, high-tech version of whack-a-mole. Is this a sustainable strategy for the West, or will it only fuel a more desperate and innovative Chinese effort? Look at history. Embargoes often accelerate the very independence they seek to prevent. The question is no longer just about capability, but about momentum. And momentum is a powerful force. Every chip that works, even inefficiently, is a data point. Every data point improves the next iteration. China is now on that learning curve, and it's a curve they are ascending alone, which can sometimes foster the most radical innovations. So, where does this leave us, the audience, to this silent war? The initial myth that China could never build advanced chips without the West has been shattered. A new, more complex reality has taken its place. It's a reality of slower, more expensive, but nonetheless real, technological progress behind a wall of restrictions. The ultimate skepticism now is about the future. Can China turn this proof of concept into a truly competitive, self-sustaining industry? Can they not only copy the tools, but also invent the next ones? That's the final frontier. The US and its allies are betting their financial and security futures that the answer is no. They believe their ecosystem of open, though now controlled, collaboration will always out-innovate a closed, directed system. China is betting its entire national destiny that the answer is yes. They are betting that will, funding, and a vast pool of talent can overcome any wall. So, the next time you hear a headline about a Chinese chip breakthrough, you'll understand the silence that follows. It's not just doubt, it's the sound of two incompatible systems, two different versions of the future, grinding against each other. It's the quiet before an unknown outcome. The machines they build and the chips they make are now more than just technology. They are chess pieces in a game for economic and strategic supremacy. And the most fascinating part? This game is being played out not with missiles, but with photons, chemicals, and the most precise machines humans have ever conceived. The money behind America and the West is watching. But the money and will behind China are now building. And the only thing certain is that the final chapter of this story is far, far from written.